Alright, so last time I was on this code. Let me see. Okay, so we taken the input encoding errors. Then I have defined a function if line. Okay, we read the line from the language file. Okay, okay. So this basically checks uh, if we haven't uh, reached the end of file, as there won't be any more lines left. Okay, so we print the line with the given encoding. Okay. So we obtain the line and strip it of any white space. Okay. Then we okay. I need to take a look at encode. I bet if I had Python dash pytalk and encode. No. Okay. First of all, yeah. Okay. So these are basically strings. So string, right? String is a IO object. I don't know. Let's try this. Okay, there we go. So this is a string object. We have creates any string, and if encoding or array is specified, then okay. Then the object must expose a data buffer that will be decoded using the given encoding. Okay, so I contain otherwise returns the value of okay encoding defaults to and arrays defaults to strict data. Okay, so that means these are all capitalized case hold center count encode. Okay, encode the string using the codec registered for encoding. Okay. Encode, what does it mean? Okay, the error handling scheme to use for encoding errors. The default is strict, meaning that encoding errors reads the Unicode encode. Okay, other possible values are ignore, replace, and as well as okay encode. And I think there must be a decode. No. I think decode should be above encode. Right, encode. C. They forgot the D. Okay, so decode, encoding, okay, raw bytes, encode. Okay, let me take a look. Split. Okay, returns a list of. Okay, but I want strip, not split. Starts with strip. Okay, returns a copy of strings leading and trailing white space removed. Here is given none. Okay, so the static methods make trans, and that is all. Okay, so let me go encode Python. Okay, encode is used to convert a string which is into a sequence of bytes. Okay, so encodes it into bytes, right? Okay, so encode the string using the codec registered. Okay, so this converts the string into bytes. This decodes the string back into UTF format from byte. Alright. So we simply print the bytes and its equivalent string. Okay. Then we are just defining, okay, opening a file, opening a text file containing all of the languages, code languages, and we supply and okay. So we have pydoc. I want open, right? Okay, so it takes encoding. Okay, right. There must be word about encoding. Mode, append, default. Encoding. Encoding is the name of the encoding used to decode or encode the file. Okay. This should only be used in text mode. The default encoding is platform dependent, but any encoding supported by Python can be passed. Okay. And additional argument which is the encoding used for encoding or decoding the text in the file. Okay. And then we simply call our main function and it is recursive. No, it is not recursive. Well, you can say that it calls, yes. Okay. So it is a recursive function which only sets if we have next line. Okay. Here the file object gets passed by reference. It automatically passes it by reference. Okay. So I got it right. Okay. So after you've done through, okay. Switches, convention and encoding. Before I get into what this code means, you need to learn some basics about how data is stored in a computer. Okay, modern computers are incredible, complex, but at their cores they are like huge arrays of light switches. Computers just use electricity to flip switches on or off. These switches can represent 0, 1 or 0, okay, 1 for on, 0 for off. In the old days there were all kinds of weird computers that did more than just 1 and 0, but these days it's just 1s and 0s. 1 represents energy, electricity on, power, substance. 0 represents off, done, gone, power down, the lack of energy. We call these 1s and 0s bits. Now a computer that only lets you work with 1 and 0 would be both horribly inefficient and incredibly annoying. Computers takes the 1s and 0s and use them to encode larger numbers. At small end, a computer will use 8 of these 1s and 0s to encode 256 numbers. Okay, what does encode mean though? It's nothing more than agreed upon standard for how a sequence of bits should represent a number. It's a convention human picked or stumbled upon, say 000 and 55. Okay. There were even huge wars in the early history of computers on nothing more than the order of these bits because they were simply conventions we all had to agree. Today we call a byte a sequence of 8 bits, 1s and 0s. In the old days everyone had their own convention for a byte. So you still run into people who think this term should be flexible and handle sequence of 9 bits, 7 bits or 6 bits. But now we just say it's 8 bits. Okay. That's a convention. And that convention defines our encoding for a byte. There are further conventions for encoding large numbers using 16, 32 and even more bits if you get into really big math. There's entire standards group who do nothing but argue about these conventions, then implement them as encodings that eventually turn switches on and off. Okay, so how you represent a byte, right? So once you have bytes, you can start to store and display text by deciding on another convention for how a number maps to a letter. Okay. In the early days of computing, there were many conventions that mapped or 7, 8 or 7 bits or less or more onto a list of characters kept inside a computer. Okay, once you have to a letter. In the early days of computing, there were many conventions that mapped this onto a list of characters kept inside a computer. The most popular convention ended up being American Standard Code for Information Interchange, or ASCII. This standard maps a number to a letter. The number 90 set, which is this, gets mapped to ASCII table inside the computer. You can try this out in Python right now. Okay, 0b is 90 and then order of 90. Okay, first I write the number in binary, then I get the number based on the letter Z. Okay, then I convert the number Z to letter char 90. Don't worry about needing to remember this. I think I've to do it twice to remember the entire time I've used Python. Okay. Okay, once we have an ASCII convention for encoding a character using 8 bytes a byte, we can then string them together or make a word. If I want to write a name Z issue, I just use a sequence of bytes like this. Most of the early text in computers was nothing more than sequence of bytes stored in memory that a computer used to display text or text to a person. Again, this is just a sequence of conventions that turned switches on and off. Okay. The problem with ASCII is that only encodes English and maybe a few other similar languages. Remember that a byte can hold 256 numbers. Turns out there's a lot more characters than 256 used throughout the world's languages. Different countries created their own encoding conventions for their languages, and that mostly worked. But many encodings could only handle one language. That meant if you want to put a title of an American English book in the middle of a Thai sentence, you were kind of in a trouble. You need two encoding for Thai and one for English. Right. To solve this problem, a group of people create Unicode. Hold up. Okay, so to solve this problem, a group of people created Unicode. It sounds like encode, and it is meant to be a universal encoding of all human languages. The solution Unicode provides is like the ASCII table, but it's huge by comparison. You can use 32 bits to encode a Unicode character, and that is more characters that we could possibly find. A 32-bit number means we can store these 2 to the power 32, which is enough space for every possible human language and probably a lot of alien ones too. Right now we use extra space for important things like poop and smiley emoji. Okay. We now have a convention for encoding any character we want. Okay. But 32 bits is 4 bytes, which means there is much more wasted space in most text we want to encode. We can also use 16 bits, 2 bytes, but still there's going to be wasted space in most text. The solution is to use a clever convention to encode the most common characters using 8 bits, and then escape into larger characters when we need to encode more characters. This means we have one more convention that is nothing more than a compression encoding, making it possible for most common characters to use 8 bits and then escape out into 16 or 32 bits as needed. The convention for encoding text in Python is called UTF-8, which means Unicode Transformation Format 8 bits. It is a convention for encoding Unicode characters into sequence of bytes, which are sequence of bits, which turns sequence. You can also use other conventional encodings, but UTF is the current standard. Okay. And you have dissecting the output. Okay, we can now. Okay, so these are our hex numbers. We now take a look at the output of the commands shown previously. Let's take just the first command and new first view. Let's take just the first command and first few lines of code. Okay, the experiment was taking bytes written inside B byte string and converting them to UTF or other encoding you specified. On the left is the number of bytes or UTF shown in hexadecimal, and the right has the character output as actual UTF-8. Okay. The way you think of this is the left side is the Python numerical byte or raw bytes. Yeah. Python uses to store the string. You use the B to tell Python this is byte. Okay, these bytes are then displayed cooked on the right side, so you can see the real characters in your terminal. Okay. Dissecting the code. Okay, we have an understanding of strings and byte sequences. In Python, a string is a UTF-8 encoded sequence of characters for displaying or working with text. The bytes are then raw sequences of bytes that Python uses to store the UTF-8 strings, and start with a B to tell Python you are working with raw bytes. Okay. This is all based on conventions for how Python wants to work with text. Here's a Python session showing me encoding strings. Okay, so we are on UTF string dot in true string decode it's true. So I go UTF. Okay, so raw bytes is this, UTF string is this. Okay, raw bytes dot decode this, say UTF string dot encode nothing. So UTF string dot encode is this, and then we say raw byte equals UTF string. Okay, equals we are comparing. Okay. Okay, so we say raw bytes UTF, then we decode, it writes this. If we encode, we get the same bytes. Okay, decoding is for okay, so decodes the string back into UTF format from bytes. This converts the string into bytes. Okay. Right, okay. All you need to remember is if you have raw bytes, then you must use decodes to get the string. Raw bytes have no convention to them. They are just sequences of bytes with no meaning other than numbers. So you must tell Python to decode this into UTF string. If you have a string and you want to send it, store it, and share it. Okay. Okay, if you have a string and you want to send it, store it, share it, or do some other operation, then usually it will work. But sometimes Python will throw up an error saying it doesn't know how to encode it. Again, Python knows its internal convention, but it has no idea what convention you need. In that case, you must use encode to get the bytes you need. Okay. Right. The way you remember this, even though I look it up almost every time, is to remember the mnemonic DBES. Decode bytes, encode strings. I say DBES in my head when I convert bytes and strings. When you have bytes and need a string, decode bytes. When you have a string, need and when you have a string and need bytes, encode strings. Okay. So we have with that in mind, let's break down the code. 1, 3 we start usual command line argument. Right, okay, so I can go Python exercise 23 or 5. I think it takes in the what does it take? Input encoding and errors. Okay, so UTF-8 and strict. Right, there we go. Okay. So we move on to start with the usual command line argument handling that you already know. I start the main meat of this code in a function conventionally called main. This will be called at the end of the script to get things going. The first thing this function does is read one line from the languages file it is given. You have done this before, so nothing new here. Just read lines as before when dealing with text. I use something new. You will learn about this in section half of the book, so consider this a teaser of something interesting. This is an if statement and it lets you make decisions in your Python code. You can test the truth of a variable. Based on the truth, run a piece of code or not run it. In this case, I'm testing whether lines has something in it. The readline function will return an empty string when it reaches the end of file. We simply test for empty string. As long as readline gives us something, this will be true and the code under will run. If false, Python will skip lines 9 to 10. Okay, I call a separate function to do the actual printing of the line. This simplifies my code and makes it easier for me to understand it. If you want to learn what this function does, I can jump to it and study. Once I know what print line does, I can attach my memory to the name print line and forget about the details. Okay, I've written a tiny yet wonderful piece of magic here. I'm calling main again inside main. Actually, it's not magic since nothing really is magic in programming. All the information you need is there. This looks like I'm calling the function inside itself, which seems like it should be illegal to do. Ask yourself, why should that be illegal? There is no technical reason why I can't call any function I want right there. Even this main function, if a function is simply a jump to the top where I've named it main, then calling this function at the end of itself would jump back to the top and run it again. Right, this would make it loop. Now loop back at line 8. Make it loop. Now look back at line 8 and you will see the if statement keeps this function from looping forever. Careful study this because it is a significant concept, but don't worry if you won't grasp it right away. Okay, I start the definition for the print line function, which does the actual encoding of each line from languages.txt file. This is a simple stripping of the trailing new line character. Okay, print line function. Okay. I finally take the language I have received from language.txt file and code it into the raw bytes. Remember debs, decode bytes and code strings. So string are to be encoded, decode bytes and encode string. The next lang variable is a string. So to get the raw bytes, I must call encode. Onto it code string, I pass encode, and encoding I want how to handle the errors. Okay, I do the extra step of showing inverse of like 15 by creating a code string variable from the raw bytes. Remember debs, I decode bytes and raw bytes is bytes. So I call decode on it to get Python string. This string should be the same as next lang variable. Okay, I simply print them both out to show you what they look like. I'm done defining functions, so now I want to open languages.txt file. The end of script simply runs the main function with all correct parameters to get everything going and kickstart the loop. Remember that this then jumps to where the main function is called on line 5, and on line 10 main is called again, causing this to keep looping. If line on line 8 will prevent a loop from going forever. Okay. Encoding deep dive. We can now use our little script to explore other encodings. The following shows me playing with different encodings and see how to break them. First, I'm doing a simple UTF-16 encoding so that you can see how it changes compared to UTF-8. You can also use UTF-32 to see how that's even bigger and get idea of a space saved with UTF-8. After that, I try Big 5 and you'll see the Python does not like that at all. It throws up an error that Big 5 can't encode some of the characters at position 0, which is super helpful. One solution is to tell Python to replace any bad characters for the Big 5 encoding. That's the next example, and you'll see it put a question mark character wherever it finds a character that doesn't match the Big 5. Okay, so we go UTF-16. Okay, everything is in bytes. Then Big 5. Then say make languages turning Unicode. Big 5 codec can't encode character this in position 0. Illegal multi-byte sequence. Okay, so we go error is replace, so it replaces it. Okay, breaking it. Okay, find strings of text encoded in other encoding and place them in exercise 3 and see how it breaks. Okay, so I'll try. Hold up. Okay, we open it in UTF-8, right? Okay, default. This is the default encoding or decoding. Okay. So Python exercise 23.py. We want UTF-16 and strict. Okay, so everything is a byte now. Right there, no. Everything is represented with a byte. Then let's try UTF-32. Right, everything is a big. Okay, see, these are 16 bytes, right? See, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. There we go, 16 bytes. Oh, this is alright. Oh no, sorry, a byte. It uses 16 bits to represent a single character. Right, 16 bits to represent a simple character. Then it uses 32 bits to represent a single character. Right, that's why these are so big. It is 32 bits to represent a single character. Okay. Then we can go Big 5. Okay, so some of the encoding are not supported. Then we go replace, so it replaces them with question marks. Big 5. Okay, find out what happens when you give an encoding that doesn't exist. Right, okay. Say Big 6. Okay, call main function. Okay, look up unknown encoding, Big 6. Okay. Extra challenging. Rewrite this using B bytes instead of UTF bytes, effectively reversing the script. Okay, rewrite this using bytes instead of UTF-8 strings. Oh, rewrite this effectively. Rewrite this using byte instead of UTF-8 string. effectively reversing the script. So what do you want me to do? Let me go. Okay. Exercise. Hey, hey. Uh, no, isn't this a bell? Uh, Wait, hold up. Okay. So I'll create a new file. Exercise 23.1. 23.1.py. Okay. So all I want to print. This should give me. This is a S key. There we go. Alarm. Okay. Okay. So from sys import argv. Wait, how about I take in the function, right? I put sys.argv and I call this, right? Okay. Hey. Wait, hold up. No. Okay. So I can do it in a single line. Okay. Okay. So we can just go Python exercise. I will open the text file 23.py. Then you go Python exercise 23.py. VTF8 strict. There we go. Import sys. Okay, so extra challenging. Rewrite this using bytes instead of VTF8 strings, effectively reversing the string. Hold up. Bytes. Give me VTF16. There we go. Now I have all the bytes and I can get rid of, okay, print raw bytes. Okay, there we go. So let's store it in a file, right? Okay. Okay, so these are just bytes. Alright. And okay, write this using bytes instead of PDF8 strings, effectively reversing the script. If you can do that, then you can also break these bytes by removing some of the space and void. How much do you need to remove to cause Python to break? How much can you remove to damage the string output but pass Python's decoding system? You use what you learned from item 4 to see if you can mangle the files. What errors do you get? How much damage can you cause and get the file past Python's decoding system? Hold up. If I simply I have bytes.py, right? Okay, so Python bytes.py, nothing happens. Subble bytes.py. Okay. Right. Okay, hold up. So let me get rid of this. Go Python ex23 UTF-8 strict. Okay. Let me put it here. Right. Okay. So let me now try and go Python bytes dot. You actually write this using bytes instead of the UTF-8 strings. Okay, so I write this using bytes instead of using strings, effectively reversing the script. I don't. Okay, if you can do that, you break these bytes by removing some to see what happens. Okay. So it didn't mean the scripts, it means the languages. Okay. So I can go languages dot txt. Right. Okay, so I get this. Right. I get this. Let's save it in. And I want to move bytes.py to bytes.txt. Then I want to open bytes.txt and let's call UTF-8 strict. Okay. So it just converts. Okay, I don't want to print raw bytes anymore. Hold up. There we go. Okay. So bytes Afrikaans. The bytes into this is bytes to play reversing. So okay. So I'll decode, right? Then I'll encode them here. Decode next line. Okay. I think I would have to see the video on this. So hold up.
Bytes out of it. Okay. Now remember, you should have read out where something comes from. Okay. Equals the errors and to the original. So on the left are the bytes. If you remember, you should already know what \x does, but it may not really make a lot of sense. There should be. You should remember that you can use the mnemonic, correct? So that code don't indicate from what to what. Okay, encode strings. Remember that. Okay, so we've got a basic understanding of PowerShell and many other computers. It takes the input encoding that we got from up here, right, from the sysarg, which is, let's see what we have. We call main, right, and main jumps up to, okay, like this. How do go return and runs again? However, there's a limitation, it would actually explode. So we'll be getting to that in a minute. And as long as you have this little if statement that you'll learn in a second, encoding errors. Okay. So on and so forth, right? Okay, pretty good. Now let's watch how main works. And you know what? I'm going to make it look a little different. I'm going to go like that. You know what? I'm going to actually do this. I'm going to have this one only do that. Okay, and then I'm going to have this one up here do more. Okay, main, and I'm going to do repr language file. File. And I'm going to do encoding and errors, and how to handle errors. Okay, so there we go. And then what I'm going to do is I'm going to do print. There's a line, right? Okay, and then I'm going to do over here print exit main. Okay, and then I'm going to do one more. I'm going to do print calling main again.
Okay.
Okay. And actually, we're going to do this. We're going to do repr. Okay, so what we've got is we're going to be able to see when we enter main, okay, what the line is, when we call main again, and then when we exit main. Okay, so what we want to do is try to predict what the output is. So take time to figure that out, and then you run it. Okay, so once we do that,
there's a line.
Scroll up. Let's see what we got. Well, you know what? I'm going to do something a little better. Give me a second here. We don't need this whole languages.txt file. One thing when you're trying to figure out what's going on is you can just shrink down the size of your test case. So let's do this. Let's try to just get it so we can see what's going on. There we go. We don't need like a whole bunch of it. All right. So we start with the command line that we ran. Okay. Now, we're at the bottom of the file. Let me side by side this real quick. That's where this first message up here is. And we see that we've got languages.txt as a file and so on. Okay. Now we go, there's a line. So we read this line, come in, this is this print statement. So we're at this point now.
Line.
And so there's a line, Afrikaans. Okay, then we do print line. So now we jumped into print line down here in line 17.
Then exit print line and then calling main again.
It does print, then we exit print line. So we come down here. Okay. And what can happen when you do this wrong? I'm going to give you one example. Let's say I get rid of this line. Okay. And do that. Now watch.
Throw the error.
Now consider this, we're switching into the breaking section now. Okay.
Ooh.
Well, it seems to just go on forever and ever and ever, right? We never see an exit. And then finally it goes maximum recursion depth exceeded. So when we see that, that means we basically called the looping function. We called the function itself, which is called recursion in computer science, so many times that it causes an explosion. What's that explosion? Well, it's just we keep piling these variables that we're using over and over again. And because we keep doing that over and over again, eventually we just run out of memory, right? Because it needs to use memory to call each time. So that's all that's happening. And it's pretty it's encode strings. Make sure that how you do the breaking, okay? And then once you've understood how that recursion thing works, you can move on to the next exercise.
Okay, more practice. Okay, so this was not extra challenging. Rewrite this using bytes instead of UTF-8 strings, effectively reversing the script. You find strings of encoded in other. Okay, find strings of encode. Okay, you want to find string of text encoded in other languages. Okay, so I was completely wrong. Right. Okay. So, like, okay, so it was this. Okay, so we find strings of encoded and encoding, place them in exercise 23.5 to see how it find strings of text encoded in other encodings and place them in exercise 23.55 to see how it breaks. Find out what happens when you give an encoding that doesn't exist. Okay. Okay, so find strings of text encoded in other. Yes, okay. Uh, Text encodings. Okay. Character encoding. Converter. Yeah. Okay. Let's see. From text to text to. No. From text encoding converter. Okay, so yeah. Okay. So this is something. Okay, so I'll try. Can't I any code converter? Okay, just numbers convert. Ah, okay. No. Characters. View and universe. Just CSS. Okay. What does it convert to? Right. Hi. I say convert. Hi. Okay, so this is UTF-32. Okay, so I want to convert UTF. Okay, so encodings. Uh, Hello there. Okay, these are UTF 8 encoding. Hello there. Okay. Okay, so I'd say okay. Find out character encoded in other encoding. Right, of course. Okay. So okay, so let me try and put this upright size. I just have a string. This. What would Python do? Okay, bytes.txt. We'll go to languages. The main calling a function to the right. Dbus. Decode bytes and encode strings. Okay, it works, right? Find strings of text encoded in other encodings. Okay. Write this using the dash bytes instead of UTF string, effectively reversing the string. If you can do that, you can also break these bytes by removing some to see what happens. How much do you need to remove to cause Python to break, and how much can you remove to damage the string output but pass Python's decoding system? Okay, find strings of text encoded in other encodings and place them in exercise file to see how it breaks. Okay, so I want to find text in different encodings. Okay, encoding. Okay, terminology, code point, Unicode, code Latin character, Eclipse. I want okay, encoding explorer. How can I? Okay, how can I? I don't get it. That okay, let's leave it. Right. Okay, what is this? More practice. Because I'll say I have okay. Use what you learned from item 4 to see if you can mangle the files. What errors do you get? How much can you get past the Python's decoding system? Okay, rewrite. Find out what happens when you give an encoding that doesn't exist. Find strings of text encoded in other encodings and place them in exercise 23 to see how it breaks. Okay. Equals 5. Let's try and see that. Oh, sorry. Okay, so that works. Okay. Let's see. String. Okay. Strings and different encodings. Bytes. Encoding. Encoding. Okay, let me see. UTF 16 strings. Okay, can I get an example? How can I get character point hex XML character binary code? So okay, क्या कहते हैं character